Example 1.3. In this example, we have a compressed air tank with a volume of 0.84 feet cubed, which has a temperature of 70 Fahrenheit and atmospheric pressure of 14.7 psi. When the tank is filled with air, it has a gauge pressure of 50 psi. We need to determine the density of the air as well as the weight of the air in the tank. In order to determine the density of the gas, we're going to use the ideal gas law, and its density is equal to pressure divided by RT. Please note that the pressure and the temperature that has to be used in this ideal gas law have to be absolute values. So we start with pressure absolute, which is equal to pressure gauge plus pressure atmospheric. So the pressure absolute is going to be 50 psi plus 14.7 psi. Therefore, the pressure absolute in this case is going to be 64.7 psi. We do the same thing for temperature, which has to be absolute, which is going to be Fahrenheit value plus 460 to make it Fahrenheit. So temperature absolute for this case is going to be 70 Fahrenheit plus 460. That gives us 530 Fahrenheit. Now we substitute these values into the equation. We have density is equal to 64.7 pounds per inch square divided by the value of R, which is given as 1716 feet pounds slugs per Rankines, and then we have 530 Rankines. Notice that the quantities for the value of R are in feet, and the unit that we have over here are inches. So we need to convert this into feet, and we're going to use simply 144 inches square is equal to 1 foot square. You need to do the conversions for the square value, not the linear value. So that's why we do not use 12, but we use 12 square. After you get these values, we calculate and we get a density of 0.0102. So now let's cancel the units. Pounds cancels with pounds, R cancels with R. Then we have that inches cancels with inches. This is feet cube, and this is slugs, and we reverse the units, and this becomes slugs over feet cube, and this is indeed a unit of density. The second step is to calculate the weight. We know that weight is equal to mass times gravity. We do not know the value of the mass, but we know the density and we know the volume, and we know that the mass is equal to the density times the amount of volume that we have. Therefore, we have that the weight is going to be equal to the density, the volume, and the gravity. We use the density that we obtained in the previous step, 0.120 slugs per feet cube. We multiply it by the volume, 0.84 feet cube, and we multiply it by 32.2 feet per second square, which is gravity, and we obtain that that value is going to be 0.276 slugs per feet per second square. Now this unit is the same thing as a pound, therefore the weight is going to be equal to 0.276 pounds, which corresponds to a unit of force. Please go back and make sure that you're able to do all the calculations and the transfer of units properly.